please take out this handout so you can follow along with the lesson. In this lesson, we're going to start looking at quadratic relations. But first, I want to do a comparison of linear and quadratic relations. So first, if you drive at a constant speed, what would the graph of distance versus time look like? Well, the key is that it's a constant speed. So for every unit of time, you're going the same unit of distance. So your graph would end up looking something like this. For each unit of time, you go up the same distance every time. So what is this shape? Well, the shape is a line. And what kind of relationship is this? Well, it's a linear relation. So let's contrast the idea of driving at a constant speed to that of launching a rocket. So this is a video I found online from SpaceX. They're showing a test launch of their rocket. And you can see the rocket starts on the ground and now it's on its way up. As it reaches the apex, it starts to slow down, and now they're trying to land it in the same spot. So now the rocket is on its way back down. So you can see the rocket is now landing back on the launch pad in the same spot. And it looks like a successful test flight for this reusable rocket. So thinking about that rocket launch, what would the graph of height versus time look like for that rocket? Well, we know it starts on the ground and it ends on the ground, and it reaches its maximum height somewhere in between. So really the height, it goes up, then it comes back down. So this shape that the graph makes is called a parabola, and this kind of relationship is a quadratic relation. So just like linear relations have a line, quadratic relations have a parabola. And just to get a sense of how these work, I have a few questions. So how would the graph change if the rocket went faster? Well, if it went faster, it would just take less time to accomplish the same task. So the graph would look something like this. It would reach the same maximum height, but it would take less time. Now, what if the rocket went slower? Well, if it went slower, it would take more time for everything to happen. So it would reach the same maximum height, but it would take a lot longer. Now, how would the graph change if the rocket started on top of a platform? Well, it would start higher, and then it would launch, and then reach back on the ground. Or it might even stop on the platform again if we're doing this reusable rocket, but the starting height would change. Now I want to compare linear and quadratic relations so that you can see the similarities and differences between them. So we'll start with linear relations. The most basic linear relation is y equals x. And all other linear relations are based on this equation. So you can see I have a table of values here with 3 different linear relations. Y equals x, y equals 2x plus 1, and y equals 0.5x minus 2. Now you've seen linear relations in previous math classes. You should be able to make a table of values using an equation. So what the equation for this first one means is whatever x is, it's the same as what y is. Y is equal to whatever x is. So if I want to calculate y, if x is minus 4, y is equal to minus 4. So y is minus 4. If y is equal to x and x is minus 3, then y is minus 3, etc. For this next relation, y is equal to 2x plus 1. So whatever x is, multiply it by 2, and then add 1. So if x is minus 4, 2 times minus 4 is minus 8, plus 1, y is minus 7. If x is negative 3, then y is 2 times negative 3, which is minus 6, plus 1, which is minus 5. And likewise for the last equation, y is equal to 0.5 times whatever x is, and then you subtract 2. So if x is minus 4, 0.5 times minus 4, well, half of minus 4 is minus 2. Then we subtract 2 again. Now we're at minus 4. When x is minus 3, y is 0.5 times minus 3, so half of minus 3, that's minus 1.5. Then we subtract 2, we're at minus 3.5. Now I'd like you to pause the video and try to finish these tables of values for y equals 2x plus 1 and y equals 0.5x minus 2. Pause the video, try it, and see how you do. So here they are. If you got different numbers, let me know and I can help you out to see what the issue was. Otherwise, now it's time to practice using your table of values to plot points on a grid. So remember, this is your x-axis, this is your y-axis, and we're going to use the scale. Each square is 1 unit. We go positive to the right, negative to the left, positive up, negative down. So for the first relationship, for y equals x is minus 4, and y is minus 4. That's 1 point. So when x is minus 4, that's over here. Y is minus 4. Go down 1, 2, 3, 4. That's where that point is. When x is minus 3, y is minus 3. So when x is minus 1, 2, 3, y is minus 1, 2, 3. We're right there. And we can fill in the rest of the points and draw a line through the points. Now, pause the video and try to draw the line for this relation, which I have in blue, and this relation, which I have in green. And you'll check back in to see how your graph compares to mine. So this is what your graphs should look like for each of these relations. Now let's contrast that with the most basic quadratic relation. This is y equals x squared, and all other quadratic relations are based on this equation. So here we have the same thing as we did before. We have a table of values for 3 different relations. So for the first one, y equals x squared. Remember what squaring means? It means you're multiplying that number by itself. So if x is minus 4, then y is minus 4 multiplied by itself. Minus 4 times minus 4. The answer is 16. For x being minus 3, y is equal to minus 3 times minus 3, which is positive 9. And when you continue that pattern, you're squaring each value of x, you end up with this. For the next one, y equals 2x squared. So we're going to square the value of x and then multiply it by 2. So if x is minus 4 squared is 16 times 2, well, that's 32. If x is minus 3, well, minus 3 squared is positive 9 times 2, well, that's 18. And for this one, looks more complicated, but same idea. We start with x, which is minus 4. So minus 4 plus 1 in brackets, that equals minus 3. Squared, that's positive 9. Multiplied by negative 1/2. So now we have negative 4.5. And then we subtract 2, which is now minus 6.5. So again, I'd like you to pause the video and try to complete the table of values for both of these equations. And then I'd like you to plot all the points on the grid to the right. So try all of that, and then you can check in to see how you did. If you did it right, you'd end up with these values and you'd end up with these graphs. Notice that all of these quadratic relations end up with some sort of a parabola on the graph. So if you didn't get some of these correct, just let me know and I can help you figure out what went wrong. Otherwise, move on to the practice questions.